The Fokker 50 is equipped with a hydraulically operated landing gear. The landing gear consists of two rearward retracting main gear and a forward retracting steerable nose gear. Each of the main gear and the nose gear are equipped with two wheels fitted on a single axle. The aircraft brake systems are hydraulically operated. The brake units are fitted to each of the main gear wheels. An anti-skid system is used to ensure efficient brake operation under all runway conditions. Nose wheel steering is achieved by a hydraulically powered steering motor on the nose gear. The Fokker 50 has a retractable tricycle landing gear. The landing gear consists of two rearward retracting main gear and a forward retracting steerable nose gear. The main gear is located in the center of the nacelles, one in the right nacelle and one in the left nacelle. The nose gear is located on the nose section of the aircraft. The main gear and the nose gear are each equipped with two wheels fitted on a single axle. The extension and retraction of the landing gear is powered by the aircraft hydraulic system. In the event of hydraulic system failure, the gear can be lowered by gravity. A tail skid is provided to prevent or limit damage to the aft aircraft structure in case of excessive nose-up attitude during takeoff or landing. The main gear is located in wheel bays in the center of the nacelles, one on the right nacelle and one on the left nacelle. Two main wheels are fitted on a single axle on each main gear. Hydraulic pressure is used to extend, retract, and hold up the main gear. Each main gear is enclosed by 5 doors. The doors are mechanically operated by the gear. When the gear is extended, all 5 main gear doors remain open. An air-ground sensor is located on each main gear. Output from the air-ground sensors is sent to various aircraft systems. The operation of many of these aircraft systems is dependent on whether the aircraft is on the ground or airborne. In the event of hydraulic system failure, the main gear is held up mechanically by means of an up-lock unit. If the hydraulic system fails, the main gear is extended using the alternate landing gear system. In alternate operation, the landing gear free falls, and the downlink spring box ensures that the lock link goes into the over-center position. What happens to the retracted main gear if the hydraulic system fails? Yes. The nose gear is located in a wheel bay on the nose section of the aircraft. 2 nose wheels are fitted on a single axle on the nose gear. Hydraulic pressure is used to extend, retract, and hold up the nose gear. The nose gear is enclosed by 4 doors. The front doors are hydraulically operated, and the aft doors are mechanically operated via linkages from the nose gear. When the nose gear is retracted, the front gear doors are held up by mechanical up-lock units. During extension of the nose gear, the forward doors open, and then the aft doors open, and the gear is extended and locked, and the forward doors close again. The aft nose gear doors remain open when the gear is extended. During retraction of the nose gear, the forward doors open, the gear is fully retracted, and both forward and aft doors close. Note that the forward nose gear doors close when the gear is fully extended and fully retracted. Which option displays the correct position of the landing gear doors after the normal gear extension cycle is complete? That's right. In the event of hydraulic system failure, the nose gear is held up by resting on the nose gear doors. Unlike the main gear, the nose gear has no up-lock unit. If the hydraulic system fails, the nose gear is extended using the alternate landing gear system. Hydraulic operation of the landing gear is controlled by the landing gear selector. The landing gear selector is located at the center main instrument panel. The landing gear selector has two positions, down to extend the gear and up to retract the gear. The landing gear selector has a blue light which illuminates when the gear is in transit or when disagreement exists between the position of the gear and the position of the selector. When the aircraft is on the ground, the selector is locked in the down position by a pawl. The pawl is automatically released by a solenoid as soon as the aircraft becomes airborne. In the event of an automatic lock release failure, the pawl can be removed by pressing the lock override button. The landing gear position lights are located above the selector on the gear selection control panel. The green indicator lights illuminate when the associated gear is down and locked. All four green lights are normally on when the gear is down and locked, and off when the gear is up. One of the green lights operates as a backup nose gear light. This is necessary because visual inspection of the nose gear is not possible. The position of each main gear can be checked through the cabin window. The backup nose gear light is powered, independently of the other green nose gear lights, by the DC emergency buzz. When the landing gear is in transit, a blue light in the landing gear selector illuminates. If the gear transit time exceeds certain limits, then the relevant amber light illuminates to indicate disagreement between the position of the gear and the position of the selector. All the lights extinguish when the main gear is up and locked and the nose gear front doors are up and locked. Which of the following statements is correct? Please touch the highlighted area. That's right. The landing gear selector is used to retract the landing gear. The selector electrically signals the landing gear selector valve. Retract the landing gear. Please touch the highlight. When the landing gear is selected up, the green position lights are extinguished. A blue light in the selector knob illuminates to indicate that the gear is in transit. The forward nose gear doors open, the main gear and the nose gear retract, and all gear doors close. When the landing gear is fully retracted, the blue transit light is extinguished. The normal gear retraction time is between 5 and 7 seconds. The landing gear selector is used to extend the landing gear. Extend the landing gear. When the landing gear lever is selected down, a blue light in the selector knob illuminates to indicate that the gear is in transit. All gear doors open, the gear is extended and locked, and the forward nose gear doors close again. The green position lights come on when the associated gear is down and locked. When all landing gear is down and locked, the blue transit light is extinguished. The normal gear extension time is between 18 and 22 seconds. The landing gear selector lever cannot be moved to the up position after takeoff if the gear selector interlock system fails. In the event of an automatic lock release failure, the lock override push button is used to move the gear selector to the up position and retract the landing gear. The lock override is operated by holding in the lock override push button and simultaneously moving the gear selector to the up position. Assume the automatic lock release has failed. Retract the landing gear. Complete the procedure. With the lock override push button held in, the landing gear selector can be moved to the up position. If the landing gear takes more than 10 seconds to retract or more than 25 seconds to extend, a Level 2 alert is presented and the amber disagreement lights illuminate. A Level 3 alert is generated if the gear is not down and locked during certain flight phases. There are two situations in which gear not down and locked causes a Level 3 alert. A Level 3 alert is generated when either or both power levers are not in the takeoff detent and the aircraft rate of descent is greater than 200 feet per minute, and either the radio altitude is below 830 feet or, when the radio altitude is not available, the indicated airspeed is below 140 knots. This alert is cancelled when all gear is down and locked, or when both power levers are moved to the takeoff detent, or when rate of descent is less than 200 feet per minute, or when the aircraft climbs above 830 feet radio altitude, or, with radio altitude unavailable, the airspeed is above 140 knots. A Level 3 alert is also presented when the gear is not down and locked and the flaps are down 22 degrees or more, or down 16 degrees or more in the case of a single engine approach. This alert is cancelled when all gear is down and locked. If the main gear lights are not working, the locked down condition of each main gear can be checked through the cabin window. A continuous red line on the lock strut indicates that the gear is down and locked. If one of the two green nose gear lights is on, it can be assumed that the nose gear is safe for landing. Which panel indicates that the gear is down and locked and safe for landing? That's right. To recap, the amber lights illuminate on the gear selection control panel if gear transit time exceeds which of the following limits. Please touch the highlighted area. Yes. The alternate landing gear selector is located on the right-hand aft side of the center pedestal. To operate the alternate landing gear selector, open the selector cover, pull the unlock handle rearward, and then pull the selector upward. Note that the normal landing gear selector should be in the down position before the alternate gear selector is operated. The normal landing gear selector is in the down position, but this has failed to extend the landing gear. Operate the alternate landing gear system to extend. Continue with the procedure. Complete the procedure. When the gear is successfully extended using the alternate landing gear system, the green lights illuminate on the landing gear panel, and the blue light in the landing gear selector handle is extinguished. Pulling the alternate landing gear selector fully up releases the up locks on the main gear and on the nose gear doors, and opens the dump valve to remove all hydraulic pressure in the landing gear and nose wheel steering systems. The gear free falls and is locked down by spring force. Without hydraulic pressure, the nose wheel steering is inoperative and the nose gear doors will stay open following alternate landing gear extension. When the landing gear are extended using the alternate system, ground locks should be installed immediately after landing. In which situation should the alternate landing gear selector be used? That's right. The landing gear on the Fokker 50 aircraft consists of two rearward retracting main gear and a forward retracting steerable nose gear. Each main gear is enclosed by 5 doors and the nose gear is enclosed by 4 doors. The extension and retraction of the landing gear is powered by the aircraft hydraulic system. In the event of hydraulic system failure, an alternate landing gear extension system is available. Nose wheel steering is achieved by a hydraulically powered steering motor on the nose gear. Nose wheel steering is controlled by one of 2 interconnected steering tillers. When the pilot operates a steering tiller, a steering control valve directs hydraulic pressure to either side of the steering motor. The steering motor turns the turning tube accordingly. Torque links connect the turning tube to the axle and ensure that the movement of the turning tube is transmitted to the nose gear wheels. The nose wheels may be turned to a maximum of 73 degrees either side of the center line of the aircraft. An electrically operated shut-off valve closes when the steering angle exceeds 73 degrees. This ensures that the steering angle limits are never exceeded. The nose wheel may be turned up to 115 degrees either side of center during towing operations. A centering actuator is pressurized when the gear is selected up. The centering actuator ensures that the nose wheel is centered and that steering inputs are not possible when the nose gear is retracted. It is effective only when the nose wheel is within 45 degrees either side of center. To check your understanding so far, what is the maximum steering angle either side of the center line of the aircraft? That's right. Which of these components ensures that steering angles cannot exceed 73 degrees? Please touch the highlighted yes. The steering tillers are located on the side panels, one on the captain's side panel and one on the first officer's right side panel. A guarded towing switch is located above the tiller on the captain's side panel. The towing switch is used for maintenance purposes and should always be in the off position for normal operations. When the towing switch is on, it disables skid control and the skid control test, and switches on the navigation lights. The towing switch can be used by maintenance personnel to provide normal and alternate brake pressure indications from the batteries when no other power source is available. The nose wheel steering system has no fault indications. Nose wheel steering is controlled by one of 2 interconnected steering tillers. Touch one of the steering tillers and observe the operation of the nose wheel steering system. When one of the steering tillers is turned, the steering control valve is selected through a steering cable loop and idler bar. Hydraulic pressure is applied to one end of the rack, causing it to move in the cylinder. The rack movement is transmitted to the nose gear turning tube via the steering motor pinion. Torque links connect the turning tube to the axle and ensure that the movement in the turning tube is transferred to the nose gear wheels. As the nose wheels turn, the feedback cable repositions the idler bar and, therefore, the steering control valve. When the wheels are in the required position, the steering valve is closed. Pressure is removed from both ends of the steering motor and the wheels are held in the new position. Castering action brings the wheels to align with the center of the aircraft when the tiller is released. During towing by maintenance personnel, the steering control valve is held in the neutral position by internal springs, and the steering tillers move with the nose wheels. Steering tillers must not be held during towing. The Fokker 50 is equipped with two brake systems, a normal brake system and an alternate brake system. The normal and the alternate brake systems have separate brake control valves, which are mechanically operated from the flight deck. The parking brake is incorporated in the normal brake system. Hydraulic fuses prevent loss of hydraulic fluid in the case of a leak in the brake supply line or brake unit downstream of the fuses. The main components of the normal brake system are brake pedals, brake control valves, a skid control unit and skid control valves, hydraulic fuses, shuttle valves, brake units, wheel speed sensors, a parking brake handle, parking brake shut-off valves, and a normal brake system accumulator. The main components of the alternate brake system are brake handles, brake control valves, hydraulic fuses, shuttle valves, brake units, and an alternate brake system accumulator. The brake pedals are located on the rudder pedals below the main instrument panel in the flight deck. The brake pedals operate the normal braking system. The captain's and first officer's brake pedals are interconnected, ensuring that a movement in one set of pedals causes a corresponding movement in the other set. The brake pedals operate the normal brake control valves, which are located near the left and right nacelles on the center wing of the aircraft. The skid control valves and the hydraulic fuses are located in the main gear wheel bays. The shuttle valves are fitted to each of the brake unit supply lines, and the brake units are fitted to each main gear wheel. The parking brake handle is located to the left of the captain's side of the main instrument panel. The parking brake handle is linked to the parking brake shut-off valves, which are located in the main gear wheel bays. The normal brake system accumulator is located in the left nacelle. This accumulator provides pressure for a number of brake applications if the hydraulic system fails. The alternate brake handles are located in the flight deck at the captain's side panel. The alternate brake handles operate the alternate brake system. Brake handle movement is mechanically transmitted to the alternate brake control valves. Spring units in the handle give feel and ensure that the handles are normally in the off or released position. The alternate brake control valves are located in front of the center wing on top of the fuselage. The alternate brake system accumulator is located in the left nacelle. This accumulator provides pressure for a number of brake applications if the hydraulic system fails. The skid control system is an integral part of the normal braking system. The skid control system functions to automatically adjust the brake pressure to the runway conditions. The main components of the skid control system are the wheel speed sensors, the skid control valves, and the skid control unit. Each main wheel axle is equipped with a wheel speed sensor. The wheel speed sensors signal the main gear wheel speeds to the skid control unit. Each main gear has a skid control valve, which in turn has one valve for the inboard brake and one valve for the outboard brake. The skid control valves are controlled by the skid control unit located in the avionics rack. When the skid control unit detects the start of a skid, it signals the applicable skid control valve to decrease the brake pressure at the relevant brake. The skid control unit receives input signals on wheel speed, on whether the aircraft is on the ground or airborne, and on whether electrical power is available or not. The skid control system is inoperative without an electrical power supply, as the skid control valves are electro-hydraulically operated. Which brake system control is located in the flight deck immediately to the left of the captain's main instrument panel? Yes. The parking brake handle operates the parking brake. The brake pedals are located in the flight deck below the captain's and first officer's main instrument panel. The brake pedals operate the normal brake system. The alternate brake handles are located in the flight deck at the captain's side panel. The alternate brake handles operate the alternate brake system. Two brake pressure indicators, one for the normal brake system and one for the alternate brake system, are located in the flight deck on the main instrument panel. The normal brake pressure indicator shows the pressure in the normal brake accumulator, and the alternate brake pressure indicator shows the pressure in the alternate brake accumulator. Power to the normal brake pressure indicator is supplied by the DC bus 1, and power to the alternate brake pressure indicator is supplied by the DC bus 2. When the towing switch is in the towing position, power is supplied to the brake pressure indicators by the ground handling buzz. Touch the controls used to operate the normal brake system. That's right. When pressure is applied to the brake pedals, the normal brake control valves open to allow brake pressure into the brake control lines. Brake pressure is transmitted through the skid control valves, the hydraulic fuses, and the shuttle valves, and into the brake units. When the pressure in the brake control lines is proportional to the force applied to the pedals, pressure is held at this level. The brake units supply the necessary friction to slow down and stop the aircraft. When the brake pedals are released, the displaced brake fluid flows via the hydraulic return system through the return point of the brake control valves, and the system pressure reverts to normal. The brakes are released, leaving the wheels free to rotate. The normal brake system allows for differential braking. To test your understanding of normal operation, which of the options completely and accurately describes the passage of brake pressure from the control valves to the brake units? Yes. The parking brake is part of the normal brake system. The parking brake is operated by depressing the brake pedals, pulling out the parking brake handle, and then releasing the brake pedals with the parking brake pulled out. When the parking brake handle is pulled, the brake pedals are held down mechanically and the parking brake shutoff valves close. The parking brake shutoff valves isolate the return from the skid control valves to the hydraulic return system. This ensures that an internal leak in the skid control valves does not result in a loss of parking brake pressure. The parking brake is released by depressing the brake pedals. Assume that the brake pedals are in the depressed position. Operate the parking brake. That's right. The skid control unit has three modes of operation: pressure modulation, locked wheel protection, and touchdown protection. The pressure modulation mode operates at speeds of more than 10 knots. Individual wheel speed is continuously and rapidly monitored to ensure that each wheel has the maximum effective braking force without skidding. A deceleration of one or more wheels is detected by the skid control unit, and the relevant skid control valves are signaled to reduce the pressure in accordance with the rate of deceleration. The locked wheel protection mode operates at speeds of more than 17 knots. The locked wheel protection mode prevents wheel speed decreasing to zero. When the speed of a wheel decelerates to a point where the wheel may lock, the relevant brake is fully released to allow the wheel to spin up. The touchdown protection mode operates until 7 seconds after touchdown, or until the wheel speed after touchdown increases to more than 35 knots. During this time, the skid control unit keeps the brake pressure at zero. The locked wheel protection mode of skid control operates at speeds of more than which of the following options? Please touch the highlight. Yes. Which option accurately describes the touchdown protection mode of skid control? That's right. The skid control test panel is located in the flight deck on the pedestal. The skid control test is performed by pressing the test button on the skid control test panel. Perform the skid control test. The skid control test is successful if the inboard and outboard lights come on when the test button is pressed and go off again when the test button is released. A skid control system fault is indicated if one or both of the lights fail to come on when the test button is pressed, or one or both of the lights remain on after the test button is released. Which of the following options indicates a successful skid control test? Yes. Finally, in the event of a fault in the skid control system, a skid control light will be presented on the center annunciator panel with a level 2 alert. Skid control will not be available, and brakes must be applied carefully to avoid blown tires. Note that landing distance without skid control is 1.86 times the distance for flaps 25. Touch the controls used to operate the alternate brake system. That's right. When the alternate brake handles are pulled, the alternate brake control valves open to allow brake pressure into the brake control lines. Brake pressure is proportional to the movement of the alternate brake handles. Brake pressure is transmitted through the hydraulic fuses and the shuttle valves and into the brake units. When the alternate braking system is used, anti-skid protection is not available, but differential braking is possible. The normal and alternate brake system accumulators are located in the left nacelle. Pressure in the accumulators provides for up to 6 full brake applications if the hydraulic system fails. The alternate brake system is used when pressure in the normal brake system accumulator is no longer available. The Fokker 50 is equipped with 2 brake systems, a normal brake system and an alternate brake system. The brake pedals are used to operate the normal brake system, and the alternate brake handles are used to operate the alternate brake system. Anti-skid protection is available with the normal braking system, but not with the alternate braking system. Differential braking is available with both the normal and the alternate brake systems. The Fokker 50 is equipped with hydraulically operated landing gear. If the hydraulic system fails, the gear can be lowered by an alternate system. The landing gear consists of two rearward retracting main gear and a forward retracting steerable nose gear. Each of the main gear and the nose gear are equipped with two wheels fitted on a single axle. The aircraft brake systems are hydraulically operated. The brake units are fitted to each of the main gear wheels. If the normal brake system fails, an alternate brake system may be used. An anti-skid system is used to ensure efficient brake operation under all runway conditions. The anti-skid system is not available with the alternate brake system. Nose wheel steering is achieved by a hydraulically powered steering motor on the nose gear.